Good morning. Today we are starting our next unit in math. It's going to start out a little bit simpler and get more complicated as we go through it. We're going to be putting lots of stuff together. This spring, I've been warning us about this. We're getting into the meaty stuff, the challenging stuff. We saw that in our last test, that last unit. People were making those little mistakes, reading about the minus and the negative, right? Forgetting to put the X on that slope-intercept form. All these little details make a difference. And it's really going to matter in this unit coming up. So when I've been saying no more gold stars for mental math, I don't want to see mental math. It's because people keep making mistakes. So I don't want to see mental math on the test at all. If you don't show your work on the test, you will not get credit for it. Okay? On the test, you're showing the work so I can see your process. We can figure out where you're going wrong. So we can learn from it. So we're not going to make those mistakes next year. All right? So get this into our minds when we do our homework. Should we do mental math? No, because we want to get into the habit of showing our work. So show your work, show your work, show your work. When I show us the steps to do, I want it to be the steps that you do. Last year I had somebody who kept fighting me on it, but I solved it this way. And I said, yep, and you're getting it wrong. And it's taking you 20 minutes to solve one problem. Solve it my way, and it will help you. Because guess what? I'm still struggling with it this year in 7th grade. Okay? Learn it now to follow the steps that the teacher has given you, and it will help you next year. We saw how complicated that math looks that you're going to be doing next year. Please, just listen to me. I know what I'm talking about. You don't know better than me, okay? Sometimes kids are like, oh, Miss Gambino, I can do it this way, it's fine. It's not fun. I have several students that struggled last spring that struggled this year, and I don't want that to be you, okay? Follow my steps. It is very detail-oriented now. Those little things matter. That negative sign matters. Making sure you've got the X in your slope-intercept form matters. So we're going to really pay attention to details. Today's objective is the first one of the unit. It's not going to be a hard, overwhelming one. We build up to those. Okay. Today we're learning vocab, what it all means. So we are starting with Po60. I can simplify algebraic expressions. So if we look at each group of objects, we're going to write each group as an expression. Remember, if it's an expression, it does not have an equal sign. Those are equations. This is just an expression, so no equal sign. So look at our first group. What do we see in our picture? Your picture is different than my picture because when it got printed in black and white, mine has soccer balls and basketballs, and it's hard to tell the difference between those two types of balls in black and white. So instead of soccer balls, you have footballs. So what do we see? Christina?
I see like 4 footballs and 3 basketballs.
Yeah. So you see 4 footballs and 3 basketballs. We're to make it that expression, we're going to make the footballs a variable, an F. 4 Fs, 4 footballs, and 3 basketballs. What operation do you think we're going to put in here? David?
Addition.
Addition. Because this group is 4 footballs plus 3 basketballs. So you don't have to put the parentheses on there. I was just showing you that this is the group we're talking about. So our group is 4 footballs plus 3 basketballs makes up our group. 4F plus 3B. So let's look at our next group. We've got lamps, chairs, and beds. What do you think that expression is going to look like based off of the expression we just did? What do you think we would put? What do you think, Vivi?
One lamp, two lamp,
So instead of lamp, because I'm not going to write the word out, what can I put?
L,
And I'm going to make it a cursive L so it doesn't look like a 1. If I were to put that regular lowercase L, it looks like a 1. I don't want it to look like 21. I want it to look like 2L. Okay, then what, Vivi?
4C, and 3B.
What was that, Rocco?
Addition,
We need to put our operations in there. We're adding all these pieces up. So those addition signs, you were saying the word and. When we say that word and, we know it's a plus sign. So we need to remember to put that plus sign in when we say the word and. All right, so we've got 2 lamps plus 4 chairs plus 3 beds. That is our group. That is an expression, different variables. So we had been working with one variable. Then we were working with that slope-intercept form that has the x and the y and the b. So we had multiple variables in there. Now we're going to look at combining those variables and those terms. And we're going to be taking it a step farther. So we talked in the last unit what a term is. So now we're going to write out that definition of a term. The term is a part of an expression terms are separated by addition and subtraction. Examples of terms would be 4C, 3B, 9, x, or negative 10x squared. That's a more complicated term, but it is a term. They are all connected together, right? So that negative 10x squared, it's all connected together, so that's one term. So that 4C that we saw up here, that is one term. 3B, those 3 basketballs, that is one term. The 9 by itself is a term. The x by itself would be a term. If there was something in front of the x, if there was something after the 9, that would be connected to the term. So terms are separated by addition or subtraction. So that's where we know where each term of our expression is. Who remembers what a coefficient is? Michael? Say that again. The number right before that y. Right? So it's the number before instead of a y, because it doesn't have to be a y. Could be a b, could be an x. So it's the number before a variable. When we were working with that slope-intercept form, it was the number before the y, that coefficient before the y, but it's any number before any variable. So if we had that term of x, what's the coefficient there? I don't see one. There?
Natural 10.
Let's look at this one. This x. You're right, over here, the coefficient was -10. What's the coefficient of just x? Does it have one? Amara? What would it be? Remember when we multiply anything by 1, we're not changing that number. 5 times 1 is still 5. So if we have just the variable, we know its coefficient is a 1. So there is still a coefficient there. We just can't see it. We have to know it. So the coefficient is the number before a variable. It tells you how many of the variable you have. What operation is happening with that coefficient in your variable? Natalie?
Multiplication.
Multiplication. We don't write it because we just know it. That number before the variable, that coefficient is always multiplying into that variable. So it's telling us how many? 3 times the basketball. So, does that make sense? 3 times the B. 9 times the Y. Okay, so you're multiplying. So an example would be 3n is n times n times n, because there are 3 of them. So for that basketball, we had basketball, basketball, basketball. Okay? Now we have a constant. A constant is a term without a variable. Example would be the number 9, the number -3, the number 11, just the number, not multiplying with the variable. How are we feeling so far? Making sense? All right, now we have like terms. So like terms are terms with the same variable to the same power. So an example would be 3x and 5x. It's the same variable of x. They're just to that first power. So like terms, we're going to be able to join together. So it's important that we know the difference in our terms. We have coefficients with the variables, different variables. They can go to different powers. We have constants. You can't combine a constant with a variable. They're different. Okay, so we're going to be working on those like terms. Simplify, 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 simplify. We know what that means with fractions. Now we're gonna find out what that means with our equations and how we can simplify those super big, long equations that I showed you from Mr. Schultz a couple weeks ago that you're gonna be working with next year. We're gonna see how we simplify them. We combine our like terms, and then we solve. Okay, so we're going to be starting up the process for what you're going to be using next year. This is why it's super important that you follow the correct steps, because you will be doing this next year. So simplifying is to combine like terms. So we're combining like terms. Key word is like. Okay? They have to have the same variable or no variable. Right? Constant is like a constant. Variable of x is like a variable of x. A variable of y squared is like a variable of y squared. They have to be the same. They have to be like. Okay, for some reason it is not scrolling on the board for me. So, in each expression below, circle the coefficients. So if it's a coefficient, we're going to circle it. If it's a constant, we're going to put a box around it. And if it's like terms, we're going to underline it. Then we're going to simplify the expression, paying attention to pluses and minuses. So let's look at our first one. We're going to circle the coefficients. So what should I circle? What are the coefficients in 3x plus 4x minus 9? Fallon?
3 and 4.
The 3 and the 4. They're both right before the variable. So I'm going to circle the 3 and the 4 because those are my coefficients. Then it says put a box around the constants. I'm going to change this, my circle. We're not just going to circle that 4. I'm going to circle the plus 4. Why do you think I changed it to plus 4, Michael? Because that means it's a positive 4. That operation matters. That operation sticks with that number that comes right after it, that term that comes right after it. So what is my constant that I'm going to put a box around? David?
The minus symbol and the 9.
Minus 9. So my constant is a negative 9. Minus 9. Now I'm going to underline like terms. What am I going to underline? Graham? 3x and the plus 4x. Those are my like terms. They both have an x for a variable. Do I do anything with the negative 9? No, because there's no like term. There's not another constant. So now I have to simplify it. I have to combine my like terms. So my like terms are 3x and a positive 4x. If I combine them, what do you think I'm going to get, Christina? 7x. So I can combine that 3x and the 4x to get 7x. What else do I need to put in my expression, Christina? Minus 9. Because I didn't have anything to combine it with, I don't just get rid of it, it's still a part of my expression. So let's look at our next one. 11 plus 8n minus 5. What are my coefficients to circle? Eleanor,
8. Wait, plus 8.
plus 8. So we're keeping that operation with what comes right after it. No other variables there, so no other coefficients. So now my constants. What am I going to put boxes around? Vivi?
11 and negative 5.
11 and negative 5. What are my like terms? What am I going to underline? Eleanor?
11 and negative
11 and negative 5. So now when I simplify, I look for my like terms, and I combine them. So what do I get? Luke?
19.
What did I underline?
Negative
The 11 and the negative 5. So if I combine 11 and negative 5, what am I going to get?
16.
So it's 11 minus 5. So what would that be? 6. Okay, so we have to be careful with those minus and negatives in what we're doing. So this is a positive 11 and a negative 5. I join them together, it's 11 minus 5, so I have a 6. And then what do I put for my expression? David?
5. Plus 8
Plus 8n. Now, you will find in the mathy world, correct expressions, they always start with the variables and they end with the constant. Y equals mx plus b. That b was a constant, right? You plug in that y-intercept, negative 5, 3, 2. There's no variable with it. So I accept this, no problem. But in the math world, we would flip it around so that constant is at the end. So we're just getting that into our heads now. It's okay if you don't flip it around in math in 6th grade, right, in pre-algebra. But in the future, as we're getting it more technical, you're going to be flipping it around to look that way. But because they're positive 6, positive 6, positive 8n, positive 8n, it's saying the exact same thing. Last one. 2y plus 9y plus 13 minus 13y. What are my coefficients to circle? Amala. 2 plus 9 and negative 13. What are my constants to box? Robbie?
13. Oh, wait, plus 13.
Plus 13. Okay, we always want to make sure our operations are all included, either being circled or boxed. Those operations always be included, so we know if they're positive or negative numbers. What are my like terms to underline? Robbie?
2 and negative 13.
So, if it's a like term, you're going to include the variable. So it's 2y plus 9y minus 13y. Because we include that variable when we simplify, when we combine them. So now we have to combine them. What do I get? Claire?
Negative 1. Wait.
What's 2y plus 9y? So negative 2 what? Y. Because remember that term includes our variable. So we have a negative 2y. Who can finish off my expression? Christina.
Plus 13.
Plus 13. Does that make sense? Thumbs up, thumbs down, thumb shaky. Where are we at? Okay, we've got 2 more rows that you're going to do later. Turn your page. Don't keep working on it. Turn your page because we want to go over our start the rest of our learning first. You'll come back to that first page. Yay. You know what? Before we do that, turn back. Let's do a complicated one together. Let's do our direct in the middle. 20n minus 3x minus 2n plus 13 minus 5. What are my variables? Not variables, sorry. What are my coefficients to circle? The one right in the middle. Who can tell me? Hadley.
20, negative 3, negative 2.
Yeah. What are my constants to box? Eleanor.
Plus 13 minus 5.
Plus 13 minus 5. What are my like terms that I'm going to be combining? Graham?
20 and 8, 2 and 8, 13 and 5.
Yeah. So I have two different things I'm going to be combining. I'm not combining them all together, I'm just combining those like terms. So I see there's a 20n and a minus 2n. So what does that get me for my n's? David?
18n.
And then I had plus 13 minus 5. So what does that get me for my constant? David?
8.
Positive 8, which is a plus 8. Then I can't forget that I had, oh, not that one. I also have an x in there that I didn't do anything with, minus 3x. I didn't have another x to combine it with, but it's still a part of my expression. So rewriting it in my Matthew way, I would do 18n minus 3x plus 8 to make it proper math. This is what some of us do on our 5-card challenge. You give me an equation like that, and then you turn it around and put it, same thing but in different order, and you call it a new equation. It's not a new equation. It's the same equation. I have minus 3x, plus 8, positive 18n, positive 18n. It means the exact same thing. So either way, it's the same equation, same expression. Okay, in the 5-card challenge, they're equations, but here it's expressions. This is the proper math way to write it, but if you wrote it that way, I would give you credit. Does that make sense? So, when we're doing this, and we're finding those like terms, don't forget, you can have multiple like terms to combine. Multiple different terms, combining our coefficient, our variables and coefficients, combining the constants, but you're only combining the ones that are the same at each time. We might have some where we have 1, 2, 3 n's. You have to combine them all, okay? So make sure you're combining all the like terms that we have, and then narrowing it down. Now we're going to go to our next page. So now we have the distributive property. I gave us a little tip into that when we did our last week's Khan Academy. Some of us got it, some of us did not. So I was explaining people how to do that distributive property, only if it came up and they didn't know what to do. Okay? But now we're going to actually learn it. So we had a heads up for it last week. So our distributive property looks like this. You'll get a number outside the parentheses, and then you'll have an expression inside the parentheses. What that means is that. So what you're doing Anybody know what operation is happening when there's something directly outside of a parentheses, Hadley? Multiplication. So it's not written there, just like when we have a coefficient right in front of a variable, we know it means multiply, but it's not written. When there's a number right outside of a parentheses, we know it means multiply, but it's not written. So the distributive property means we multiply that number through. So A times B, A times C. And then whatever operation we had in between them, we keep that same operation. So that distributive property just means we're gonna multiply it through all of the terms inside the parentheses. Does that make sense? So, simplifying each expression using the distributive property. Show how you are distributing. Pay attention to the signs. So when it says show how you are distributing, you're going to draw that line. 8 times n is 8n. 8 times positive 7 is a positive 56. So show how you are distributing. Actually do the motion of drawing that line, making sure you're multiplying each term in the parentheses. You draw your line and then you multiply it. 10n, 10 times n is 10n. 10 times positive 5 is a positive 50. What would this next one be? Who could do that next one? 6 outside the parentheses of 2n minus 4. I have one person who thinks they can take a stab at it. What do you think, Mark? What do you think? 6 times 2n minus 4. Which would be what? Which would be? Yeah. Because we had that minus there, we have to keep that minus. So negative 4 times 6 is a negative 24. We look down below it. What do you think we have to do to this one? This one looks a little more complicated. Alex, what do you think? What's going to be our first step? We think about PERMDAS. In PERMDAS, do we add first or do we multiply first? We have to multiply first. And there's multiplying right there by the parentheses. So our first step is going to be to multiply through doing that distributive property. So we would do 8 times negative 2n, which gives me negative 16n, and then 8 times negative 7 gives me what? Graham? Negative 56. Now I'm going to bring straight down what I have here, my 2n. Now what do you think I have to do, Graham? I have to simplify it. I have to combine my like terms. So what terms am I going to combine, Graham?
2n minus 16.
Which is going to give me what? 2n minus 16n. Negative 14n. And then I bring down what I have left, minus 56. So when we're combining like terms, that's when we're adding or subtracting, when we combine them. So it's not multiplying, okay, even though we know 2n is 2 times n, right? We're not doing that. We're adding 2n and negative 16n. So it's 2 minus 16, 2n minus 16n. So we get that negative 14n, and then we have that minus 56. So we have to be really careful that we're paying attention to, are we multiplying or are we adding? Okay. Is it a positive, is it a negative? That operation always sticks to the number that's right after it. Always, always, always. That operation sticks to the number after it. And then our final step is always simplifying. With fractions, can I simplify it? When we're combining our terms, always see, can I simplify? I did the distributive property, and then I check, can I simplify? Simplify, simplify, simplify. Combine your like terms. Now the bottom section says, choose a value for the variable and check to see that the original expression and your simplified expression have the same value. So let's see what that means. What's 3n plus 9n? Eleanor? 12n. So now I'm going to check it to make sure I am simplifying correctly. So I'm going to give myself a number that I'm going to put in for the n. So I might say a 2. If I say n equals 2, I should get the same answer here that I would get for putting a 2 in for the n up above. What is 12 times 2? Christina? 24. So I'm going to go back to my original expression, and I'm going to put a 2 in for each of my n's. So now I have 3 times 2, which is what? 6. And I have 9 times 2. And I'm adding them. What is 6 plus 18? Christina? 24. Did I simplify correctly? Yeah, because 24 equals 24. Don't just guess and say, oh yeah, it's going to be equal. Actually work through this math. Work it through to make sure that's your checkpoint. Did I do it correctly? Eleanor?
Could we use 1 for the n?
I would think so. You would get the same answer. It doesn't matter what variable you use. You could use 1. You get the same answer. Any other questions? The top ones aren't as complicated. It gets more complicated when we have distributive properties with other parts that we need to simplify and add in. That's why we check it. So any questions at all? Remember, with math, it's okay to have homework. Do not rush through and say, oh yeah, I got it done, woo, no homework. But then you do it incorrectly because you're not learning. We want to learn this. We will see stuff like this on the math test in a few weeks. So make sure you're taking your time and learning how to do this. This unit gets more complicated as we go. Put the time in now, doing all of the steps, no mental math, all the steps, so we learn it, so this unit goes smoothly. All right, if you are listening at home, I hope you are well, and I hope to see you soon. Make sure you ask me if you have any questions. Have a wonderful day.